Hello guys, and welcome to today's chemistry class for SS1. Our topic today shall be elements, but we will be taking part 2 of this topic. Lesson objectives. At the end of this lesson, the student should be able to define valency, classify elements. Let me start this class by asking you this question. Do you know what the electrons in the outermost shell of an atom are called? If you don't know, hang on, you will soon know. So let's start with valency. What is valency? Valency is defined as the combining power of any element. In a layman's language, it's as good as saying the amount of vacancy the atom has to be able to combine with other atoms during bonding. This can be determined based on the number of electrons that will be added or lost or shared if it reacts with other atoms. Now, valency is denoted using a positive or negative integer to represent that binding capacity that we talked about in the last slide. For example, common valencies of copper are +1 and +2, while oxygen has a common valency of -2. Valence electrons are the electrons in the outermost shell of an atom. They exactly are the ones that determine the valency of an atom. So, if an atom has 1 electron in its outermost shell, it will likely have a valency of 1. If it has 2, it will have a valency of 2, etc. Also, the number of valence electrons indicates the group that the element belongs to on the periodic table. For example, an atom of an element with 5 valence electrons will be in group 5. The one with 2 will be in group 2, etc. So, we can take a look at this slide and see for ourselves. Here we have the atomic numbers of the elements to your extreme left. In the middle, we have the names of the elements, and to your extreme right, we have the valencies of each of the elements. So we start with hydrogen. You can see it has a valency of 1, meaning it has only 1 electron in its outermost shell that it can share or it can use to bond. Helium has 2 electrons in its outermost shell. That is a stable triplet. It has no electron to share. That is why it has 0 as its valency. Don't forget, all group 0 elements are also called 8 elements. They are also called rare gases. They do not have any combining power because they do not react ordinarily on their own. Lithium has a valency of 1. Beryllium has a valency of 2. Boron, you can see, has a valency of 3. Carbon has a valency of both 2 and 4. Don't forget, some elements can show more than 1 valency. So, if you have such a situation, the elements mostly show the higher valency. You can see nitrogen having 3 and 5. Of course, it will show 5 more. Oxygen has a valency of 2. Fluorine has a valency of 1. Neon, that is in group 0, will have a valency of 0. And sodium in group 1 will have a valency of 1. Just like I told you, the number of valency will always tell you the group to which the atom would belong to. And so guys, let's go on and talk about classification of elements. Elements are normally classified into metals, non-metals, and metalloids. Now, the metals are those elements which ionize by electron loss. They normally lose electrons. Examples are calcium, magnesium, iron, etc. And you can see we are using magnesium as an example here. You can see how magnesium to your right hand side will lose 2 electrons to become Mg2+. Now, the non-metals are those elements which ionize by electron gain. Examples are chlorine, oxygen, nitrogen, iodine, etc. You can see we are using chlorine as an example. When chlorine gains 1 electron, it becomes Cl-. Now, the metalloids. The metalloid describes a chemical element that forms a simple substance having properties intermediate between those of a typical metal and a typical non-metal. Essentially, the metalloid is not a metal, is not a non-metal, but has properties mixed of both of metals and non-metals. So, let's take a quick look at differences between metals and non-metals. Now, as you can see on this slide, on the right hand side we have the non-metals, while on the left hand side we have the metals. So let's take them one after the other. Metals are malleable, they are ductile and sonorous. Now I'll quickly explain here that malleability simply means that the metal can be beaten into sheets, while ductility, the ability of being ductile, means the metals can be drawn into wires. Sonorous means they give out a musical note, they give out a musical sound when hit. But on the side of the non-metals, you can see that they are not malleable, they are not ductile, they are not sonorous. Let's go on to the second point. Metals have a great tensile strength, that is, they don't easily break or bend. While on the other side, non-metals are very brittle and soft. They can easily break. Think about you trying to bend an iron nail, or you trying to break a broomstick or a small wood. Metals are lustrous. That means they have this shiny look, while non-metals are non-lustrous. Metals are good conductors of heat and electricity, while non-metals are very poor conductors of heat and electricity, except of course graphite. Metals have high melting and boiling points, while non-metals, except carbon, have very low melting and boiling points. They have relative high densities, while the non-metals have low densities. So, we can go ahead now to look at the differences between the properties, chemical properties of metals and non-metals. Now, you can see we have put the properties of the metals to your left, and then the properties of the non-metals to your right. Now, the metals, they are reducing agents. They have the tendency to ionize by losing electrons to form cations. Cations usually are called cathode ions. That means ions that normally migrate to the cathode during electrolysis. While the non-metals are oxidizing agents, they tend to ionize by gaining electrons to form anions. Anions here means anode ions, that is, the ions that go to the anode during electrolysis. Now, the metals usually form basic oxides when they combine with oxygen. That is, the oxides that they form are basic in nature. They display the properties of base. While The non-metals form acidic oxides when they combine with oxygen, such that their oxides will have acidic properties. The metals can be very reactive to the extent that they will displace hydrogen from acids. Don't forget that hydrogen is the main thing that makes an acid an acid. In the definition of an acid, you have been told that an acid is a substance that can produce hydrogen as the only positive ion when dissolved in water. So, reactive metals have the ability to displace hydrogen from acids, while non-metals cannot displace hydrogen from acids. Metals generally tend to form ionic compounds, that is, compounds that can ionize, while non-metals easily form covalent compounds. Summary. In this class, we have studied valency. We also spent time to study classification of metals. We also went ahead to talk about valence electrons and their uses, how they can be used to know the group that an element will belong to on the periodic table. And finally, we studied the differences between physical and chemical properties of metals and non-metals. And so, it's now time for us to take an assessment to see how far we have studied. Question number 1. What is valency? A. The number of atoms in a compound. B. The number of electrons in the outermost shell of an atom. C. The number of protons in the atom. D. The number of neutrons in the nucleus. Number 2. Dash are elements which ionize by electron loss. A. Metalloids. B. Metals. C. Non-metals. D. Ions. Which of the following is not a property of metals? They are A. Malleable. B. Ductile. C. Sonorous. D. Brittle. With this, we have come to the end of today's lesson. Thanks for watching and see you in the next lesson.